Hello fam, this is our solutions video for Can You Do number 5. Before I get into the video, there's two things that I want to make sure that you have done or have you do. So the first thing is, one of the problems on this Can You Do was actually very challenging, and I had a hard time getting started without looking at the solutions in the back of our textbook. So I'm imagining that some of you guys had the same troubles. I'm going to help you with that problem and then start going over the solutions. So if you have not started number 49, I'm going to give you some guidance on number 49, and then I want you to stop the video and try it and then come back and watch the solutions. So if you have not done 49, it's the women and men studying. I'm going to give you some guidance and then really, for realsies, pause the video and go and try it, because I'm sure that once I give you this info, you will be able to do it. So we have our women and our men split out, and they have reported how many minutes they study on a typical weeknight. So part A says, examine the data. Why are you not surprised that most responses are multiples of 10 minutes? Well, I think that reporting in multiples of 10 minutes makes the most sense. Like, nobody's going to say I studied for 62 minutes. They're going to round down to the nearest. So they're going to say I studied for about 60 minutes. Nobody's really going to say that they studied for 88 minutes. They're going to probably round up and say I studied for about 90 minutes. So why do I think they're in multiples of 10? I think that that's just typically the easiest way to quantify how much we study. Are there any responses that you consider suspicious? In the women's side, you have somebody that studied for, I think it was 300 minutes. Maybe it was the 240. And on the men's side, you had, so the men had the one with the 300, and the women had one with 360. I think that those numbers are unusual but not suspicious. So unusual but not very suspicious. Don't be suspicious. Don't be suspicious. Did you guys see all those on the TikToks with the animals that would get in trouble and the owners would play that song and bust them doing something bad? Okay, anyways, sorry. So I think, like I was saying, 360 and 300 are suspicious, but not suspicious, sorry, just unusual. This would be studying for 6 hours on a typical weeknight. This would be studying for 5 hours on a typical weeknight, depending on what your area of study is. I mean, maybe this is pre-med, a doctorate, being a lawyer, going into pharmacy. I can see these guys having to study quite a bit. Or those guys. Okay, then the next thing it says is make a back-to-back stem plot to compare the two samples. Well, this is where things get really hard, because if you try to break this down, your min is 30. Nope, just kidding. Your min is 0. And your max is that female or that woman that studied for 360. So I was thinking, okay, well, I'll just make my stems 0, 0, 0, 1, 0, 2, so far, so forth, all the way up to 36. But then I thought about it and I was like, there's no way they want us to make our stems that way, because if we did, our stem would be the entire length of this page. We would have to go from 0, 0 all the way up to 36. And in that case, that just seems ridiculous. It's not that we can't do it, and it's not that it wouldn't show us the shape of our data. I just know that for a stem and leaf plot, you would never make your stems so that they were like more than half a page long. So that's when I looked in the solutions manual, and this is going to help you with your stems. So the key that they use is that 1 bar 5 would be 150 minutes. So essentially, whatever is in your stem plot, you add a 0 on the end. So now that means you can go from 0, 1, 2, 3. But we've talked about if you only have 4 stems, you're really probably going to want to split out those 4 stems. So I'm going to turn my page because that's where we show work. And I'm going to go 0, 0, sorry, you can't see that. 1, 1, 2, 2, 3, 3. So this number is going to be 0 to 50. This number, sorry, not 50, 40. This one's going to be 50 to 90. This one's going to be 100 to 140, 150 to 190, 200 to 240, 250 to 290, and so on. So now that we have that, maybe let's lay down the first few. So I'll do the men's side first, which reminds me of the other thing that I wanted to tell you. So, okay, pause, teacher, get a grip. So I'm going to do the first column on the men's data. I'm going to do the first column on the men's data. So I'm going to do this column right here. So for 90, that would go on the upper 0 stem. This is equal to 90. So what it really looks like is 0, 9, 0. Well, you guys know that that 0 on the front doesn't matter, so it's just 90. Then we had another 90. Then we had a 150. So that's what 150 would look like. Because remember, you add a 0 at the end. Then 240. That's 240. Then 30. That would be 30, and then 0. You do actually have to put the 0 there. So this, as weird as it looks, would be 0, 0, 0. So you want to list them out like that, and then do the women on this other side. Well, if you start going through these data points, once you start on the next column, all of a sudden you run into a 45. And how are you supposed to make a stem plot with a 45 with that key? So what your book did was round all of these up to the nearest 10. So they changed 45 to 50. They changed 95 to 100. They changed 75 to 80. So on all of these observations that were I shouldn't say half of 10 minutes, that had a 5 on the end, just round up. So I'm thinking that that is enough to get you started on this problem. I'm going to do one more column on the men's for you. And then I'm going to have you try this on your own. Maybe I should do one on the women's too. I just didn't do the women's side because I wrote all this stuff here for your reference. So maybe I'll just quickly draw this. If you don't need this, hopefully you're skipping ahead to find out where I'm really talking about the solutions. Okay, so I'll do it on this one. Let me find my data. So the next column for the men is 120. So it'd go here, 50, 120, 60, 230, 200. So this is the men. So now let's do the same for the women. I'm just going to do the first column. So for the women, the first one is 180. So that's your upper one stem. 120, 150, 200, 120, 90. And once again, round up on these if you get to one that has a 5 on the end. So, like I said, if you haven't done this problem yet, pause the video, go back, do this problem, and then check your solutions. The other thing that I have is for both 2B and 3B. So this is for 2B and 3B. 1A, when you watch this, well, maybe just watch it the whole way through just in case. But we started doing back-to-back stem plots on the B days. So if you're on an A day, just hang tight really quick and listen to this just in case, and then you can move forward. So specifically 2B, I want you to make sure that you have the same data as me because I added on 3B's data after your class period. So find this, pause the video and go find this. And then I want you to add on these data values. So for the girls, after the 8, you need to add on 3, 3. After the 5, you need to add on 2, 5, 0, 0, 1, 2. After the 3, you need to add a 1, 8. And then you need to put in a 40. So by the time you're done, everybody should have 32 observations on the girls' side. Then for the boys, you don't have to add as many. On the 0, you need to add a 4, 5, 3. On the 1, you need to add a 2. And I think that that's it. And when you're done, you should have 22 observations. Then your instructions, and I don't know if I got this far with 2B or 3B, but regardless if you're in 2B, 3B, or 1A, the next task that you have is to not only order your leaves, but go through and split your stems. So split stems, and then order your leaves. Split stems, order leaves. And then lastly, I don't mean to, what's it called? Spur this on you? That doesn't make sense. I don't mean to surprise you with this, but I want you to practice comparing distributions one more time. And I know, or maybe it's just me, sometimes I feel like comparing distributions is very tedious because of the amount of stuff that you need to write down to compare the distributions. But if we want to pass this exam, we got to push through, we got to do the annoying thing, we have to compare the distributions, and we have to do it a lot so that by the time we get to the AP exam, it's not taking us 20 minutes to remember how do I do it and what are the things I have to write down. We're going to be rewarded for how many times we practice this and be able to answer this question in less than 5 minutes. So what I want you to do is either on this paper or on the back, so either on this page or on the back, I want you to compare these distributions. I want you to write it down and I want you to compare them, and I want you to do that right now. So pause the video, everybody pause the video, compare the distributions, and then come back. I'll show you the solutions, and then I'll show you all of the solutions for the Can You Do. Okay, hopefully you really paused. So my stem perhaps isn't the most beautiful one that's ever existed, because by the time I got done comparing things, I wrote a lot on my stem and leaf plot. So this is what it started as over here. I'll zoom in. You can pause for a second and double check to see if yours is right if you'd like. So I first got the stem plot done, and then I looked at shape. So for the girls, I have to turn it on the side. Sorry, for the boys, turn it on its side so that the numbers are going least to greatest. So from 0 to 5. You can see that it's right skewed with a potential outlier at 40. Now for the boys, I find it easiest to just hold my paper up to the light. I don't know, I guess I can just show you on, make myself big. I hold it up to the light so that I can see through my paper the girl's side on top of the stems going from 0 to 5. And the easiest way to do this, like I said, for me, is to hold it up against the light so that it's going from 0, from the smallest to the biggest, and the distribution that I want is on the top. So if I do that, I can see that it is right skewed as well, with a definite outlier at 58. I think I had these mixed up, I'm sorry, but this side is the women's side and this side is the men's side. If I said that backward, I apologize. So for the girls, I personally think that 40 might be an outlier. For the boys, I absolutely think that this 58 is an outlier without calculating 1.5 times IQR. So that's where I started. Both distributions, oh, I didn't actually start that way. I said both distributions of shoe ownership are right skewed and unimodal. The distribution for the boys has an outlier at 58, and the distribution for the girls has an outlier at 40. And part of why my stem and leaf looks so messy is because I knew for sure that this was going to be an outlier, but I wasn't 100% sure on this one because I don't know that from 30 to 40 it would really be an outlier. So I just thought I'll plug it into my calculator really quick and I'll find the IQR and find the upper bound. I didn't find the lower bound because you have a built-in lower bound at 0. So I checked the upper bound and it was 35, and I was quite surprised that that actually was legitimately an outlier. So 40 is a legitimate outlier. Well, then that got me thinking, well, I know 58 for sure is an outlier, but is this 21 an outlier? Because if this is an outlier, I was worried that this was also an outlier. So I calculated the upper bound for the boys, and I did this one by hand because their data set was smaller. So this is my quartile 1, this is my quartile 3, and I got an upper bound of 20.5. So no, this is not an outlier. 58 is for the boys, 40 is for the girls. I don't think that they are expecting you to use 1.5 times IQR to determine your outliers if they gave you a problem like this, but if you have that skill and it's quick, you should use it. If you have the time, you should be thorough. If you don't have the time, then you eyeball it and you say 58 is for sure an outlier and 40 might be an outlier, and then you get on with the show. So, okay. So I did shape and outliers. So now I'm on center. Girls typically own more shoes than boys. The median for the girls' distribution is 14, but the boys is only 5. So girls own about 14 shoes on average and boys only own 5. Girls' shoe ownership varies more than the boys. The IQRs are 10 and 7 respectively. So for the girls, it varies by 10 shoes. For the boys, it varies by 7 shoes. But also you can just see in the graph, like most of the boys' data is right here. but for the girls, it's like twice as spread out. So for the boys, it is less spread out than for the girls. Without these outliers, the range would have been a better description of spread, I think, but because of these outliers, it's probably not a great idea to use them. I calculated IQR because I had already done it to see if there were outliers. If you didn't calculate IQR, what I would have done instead is say the boys' data ranges from 2 to, well, that's backward. Is it? Yeah, that's backward. Whew, it's a good thing I looked at that. Sorry, the boys' data varies from 2 to 21, and I would leave out that outlier, and then I would say the girls' data varies from 3 to 30 and leave out this outlier. And if you compared that, this range without the outlier is 27, and this range without the outlier is 29. Oh, so maybe we shouldn't use that. Do you see the problem I'm running into there? Because this is so big, it's making it seem like the boys is way more spread out than the girls. Did I do this one right? Yeah. So IQR probably is the better one. Or maybe you could say most of the data from the girls is from 3 to 30, but most of the data for the boys is from 2 to 13. That's probably the best way to say it if you're not going to find IQR. So if you're not going to find IQR, I would say most of the data is between 3 and 30 for the girls, or even 3 and 23 if you wanted to cut it down that far. But most of the data from the boys is from 2 to 23. So I'm going to say most of data here, and I'm actually only going to go from 3 to 23, and then most of data here from 2 to 13. And how many minutes are we at? We're already at 22. So I often wonder if anybody really watches these, and sometimes I feel like there's no way that any kid has sat through all of this. Like, if you go through the amount of time that I have recorded for lessons, for quiz solutions, for can you do solutions, it's so much time that I just have a hard time believing anybody has persevered. But if you've persevered, I really appreciate it. I almost want to cry because I spend so much time here and I want to do that. I want to be here to help you guys. But man, when it's Thursday at 4 o'clock and I just want to go home and I'm sitting here thinking, I've been babbling on for 20 minutes. Is anybody even watching this video? I start to question whether it's worth it. But here's what I know in the end. If you make it through these, if you're actually listening to this right now, I think that the likelihood that you are going to pass your exam is very high because you get so much information from doing this with me that I just can't see you not being rewarded for the time that you put in. And for stats, sometimes it takes a lot of time. Sometimes you got to watch the solutions videos, and I know that that's not awesome, but if you're doing it, I'm proud of you, and I do think that you'll be rewarded. Okay, so on with the show. Sorry about that. Make myself small again. So, yes, that is the very long explanation for comparing the shoe data for the girls and the boys. I honestly thought that maybe the girls and the boys would be closer because I think for your generation, boys are a little bit more interested in shoes than they were for mine. But it looks like the trend is continuing where girls own a lot more shoes than boys. Okay, so we are officially done with this displaying quantitative data packet. We are officially done with this guy. And now we are moving on to your can you do solutions for can you do number 5. So this is actually a really good question, number one, and I would not be surprised if you see it on your AP exam or a unit test for this class. So 1.6 million first-year students enroll in colleges and universities. This is a graph of what they plan to study and its percentages. This says, is this a bar graph or a histogram? Explain. This is definitely a bar graph. The first and easiest way that I know that is because the bars aren't touching. If the bars don't touch, it can't be a histogram. The second thing that makes me know that this is not a histogram is look at your x-axis. It's not numbers, it's words. So it probably feels like a million years ago, because it certainly feels like a million years ago to me, but we've talked about categorical data, and if you really think about it, there's only two ways to graph categorical data. You get a bar chart or you get a pie graph. That's it. So this is definitely categorical data. So this has to be a bar chart. You only use a histogram for quantitative data, and the bars are always touching. I have spelled bar here with an E. Okay, teacher. This is an essential understanding. For categorical data, your only options are bar graphs and pie charts. This is categorical data. So the next one, would it be correct to describe this distribution as right skewed? No. So we are done learning about categorical data. We have finished that part of Unit 1. Hopefully you're aware that we didn't talk about the shape of categorical data at all. We've just recently started talking about shape, and that is in relation to quantitative data. Categorical data does not have a shape because it would not make sense to say that this distribution is skewed toward the physical sciences and tech. That doesn't make sense. It's not skewed toward the right. It's not skewed toward these subjects. You don't look at the shape of categorical data. You look at the percentages or the numbers in each category. So hopefully that description helps you out a little bit on no, this is a bar graph, and no, you would not describe it as right skewed. Okay, turn the page. We have this question about the Phillies and the Yankees. So the first question is, why can't we use the graphs to effectively compare the team payrolls? The first issue is the number of players aren't the same. You cannot use frequency on the y-axis unless your number of observations is the same. So this was on the back of your comparing distributions page. We had a specific page on comparing histograms, and we talked about how you cannot use frequency unless you have the same number of observations, and if you don't, then you need to use relative frequency or percents. So that's our first issue. Even though they're close, it's still better to use relative frequency. The other issue is the scale on the x-axis. Their bins are not the same size. The bins here, I don't even know, what are they, 5 million? I don't like the way that they did this x-axis. And here, it looks like the bins are 1 million. Honestly, it's really hard for me to tell, but the scales are different on the x-axis. So then they fix it, I hope, or they fix the x-axis. So apparently your book didn't feel like it was a huge issue to compare these, even though the Yankees have 26 players and the Phillies have 25. I don't really like that very much, but whatever. I'm just going to get on with the show. So they change both histograms so that the bins are 4 million instead of being different. So we compare the distributions. Both salary distributions for 2008 are right skewed and unimodal. And when I'm comparing these, I'm adding in as much context as possible. So I'm being specific to what these graphs say. I'm not just saying both distributions are skewed right. I'm saying both salary distributions for 2008 are skewed right. Yankees players typically make more than Phillies players. The median for the Yankees distribution is from 4 to 8 million, whereas for the Phillies distribution, it is 0 to 4 million. The salary for Yankees players vary more than the salary for Phillies players. Phillies salaries only vary from 0 to 16 million, but Yankees make up to 34 million. There do not appear to be any outliers in the salary distribution for the Phillies, but the Yankees player that makes 32 to 34 million is likely an outlier. So I'm not saying definitely an outlier, and I am not going through and calculating IQR and all that jazz. I'm pretty sure that he's an outlier. I think it's very likely that he is, but I'm not going to commit to that and say it's for sure an outlier. So I'm saying likely an outlier. So now you can see my whole response on the screen and pause and change things on your paper if you need to. Do you need to write this much? Yes, you do need to write this much. I apologize. I know that that's a lot of stuff to be writing, but the practice is going to pay out in the end. You want to be as specific as possible. Okay, now we're on to that really weird stem and leaf with the interesting stems. So you can pause this here if you want to double check that ours look the same, but this is what I ended up getting. I have the median for each calculated, and then I have the key of how to read it. This question doesn't say compare the distributions though. This question says, if I have it here, I'll just read it. This question says, does it appear that women study more than men? Justify your answer. So here's my response. It does appear that women study more than men because the median for the women's distribution is larger than the median for the men's distribution. Female first-year college students typically study about 175 minutes on a weeknight, but male first-year college students typically study for only 120 minutes on a weeknight. And I probably should have said on a typical weeknight. If you didn't, like I didn't, you're fine. You're okay. So hopefully that one is helpful now. And we're finally on the back side. So you had to determine which distribution can match what data. So are you male or are you female? Even though they're assigning a 0 and a 1, this is categorical data, which means that your bars can't be touching. So it has to be either C or B. 2, right-handed or left-handed, same idea, 0, 1, but this is also categorical data. So this is 0, this is 1, this is 0, this is 1. So I first knew to choose handedness for this, whether you're left or right-handed, because I was thinking, well, this is probably people that are right-handed, and this is probably people that are left-handed, because I don't know hardly any left-handed people. So I think it's way more common to be right-handed than left-handed. So I chose handedness for this first one. Then for the bottom one, that left me with male to female, but this makes sense to me because if we're in a classroom of kids, we probably should have close to half of them being male and half of them being female. Or if we're looking at a population, we probably are seeing about half of them are female and half of them are male. Why? Because there's only two choices. 50% you'll have a girl and 50% you'll have a boy. I know genetics and stuff like that factors in, but I'm just saying that on average, half of the people should be male and half of the people should be female, and these were closer to that. So this made sense to me. It made sense that these were closer in height, but this one would be very, very taller. That's not a great expression than this one. Okay, what is your height in inches? That's definitely quantitative. How many minutes do you study? Quantitative. And hopefully the problem 49 that we just talked about helped you decide which histogram is the studying. Studying is typically right skewed. You have a built-in lower bound of 0, but then you've got some people over here studying way more than others. Now, I know just from life that height and like your arm length and your head circumference and all that stuff are distributed like this. It's called a normal distribution. So I just know from life experience and teaching this that height, all distributions of height, like if we took the height of the people in our class, all distributions of height look like this. They have a peak in the middle and then it comes down nicely on both sides. Okay, last one. Choose a graph for the different sets of data. Explain your choices. Which radio stations are most popular? I personally would use a bar chart because I prefer a bar chart in general. I'm not a huge fan of pie charts. You could have said pie chart and that's just fine, but I would use a bar chart. And why? Because it's categorical data. And remember, your only options are bar chart and pie chart. How many hours per week do students study? I said a stem plot or a dot plot is manageable because I don't think the range is going to be very large. I mean, for the example that we saw on problem 49, that range was quite big. But like for us, we're usually talking about, do you study 1 hour, 2 hours, 3 hours? We're not talking about minutes. So I think a dot plot or a stem plot is reasonable. But if you want to talk about the number of calories students consume per day, I'm definitely going to use a histogram because of how varied the calories people consume can be. Like, we're talking 0 to 4,000 calories, maybe even 5,000 calories. I bet you our athletes eat so much food. So if that's the case, you're going to want to use bins instead of stems or numbers on a dot plot. So my reasoning was if it's hours you study, it's probably looking like this. So that can easily be done as a dot plot or a stem plot. But if you're doing calories, there's so many calories from 0 to 4,000 that a histogram would be better. Okay, that's it. I always think that these things are going to be so fast, and then 40 minutes in, I'm feeling really bad for you guys because who wants to sit around for 40 minutes and watch their AP stats teacher talk about the problems from the homework? But love you guys. That's why I do it. I hope things are going well. If you have questions, send them to me. Otherwise, I'll see you in class next time.